My name's Grace. I'm a Cloud Solutions Architect based out of the London office, just in case there was any confusion where I came from. And I'm here to talk to you about blending GCP security controls. When it comes to security, there kind of tends to be two approaches. Thinking about what your users are allowed to do, and also what's permitted within your organization, and then also what protecting against threats and concerns and the controls you need to do approach there. So as you would expect with GCP, we have a selection of controls, and these are just a subset. And this talk is all about demystifying how you can pick and choose various controls to address particular use cases. Starting off with the first one, which is what can your users do? When it comes to permissions, IAM dictates what your users can do. It dictates who can do what on which resource. But before I go and talk to you about how you implement IAM in GCP, I need to talk to you about the Cloud Resource Manager. The Cloud Resource Manager allows you to map your organization. It's a hierarchical organization. So you can map your teams, or maybe how your applications are configured to map to your GCP. In the context of this talk, the thing is it provides hierarchical attachment points for permissions and organization policies. Okay? So coming back to IAM, when you use IAM, you have to create an IAM policy. An IAM policy, you bind users to a set of permissions, and the set of permissions are called roles. These are the users that GCP recognizes, but it doesn't preclude you from bringing your own identity along. So you can use Active Directory, you can use LDAP. So once you've defined your policy, you then need to decide where on the hierarchy you need to attach it. So whether at the organization level, folder level, the folders have a collection of projects within them, project, or even at the resource level themselves. As on-prem, in GCP, as on-prem, you have a number of privileged roles, like your super user accounts. So these are the ones that you really, really need to give least privileges and restrict the number of users who use them, who are granted them. So the policy admin gives you, that person who has that role, the ability to have organization manager and policies all throughout the organization. The organization role admin, it gives them the ability to create custom roles that apply throughout the organization. And policy admin, folder, and project owner are pretty self-evident. So what you need to do is you need to think about what roles your users actually have, i.e., are they central network and security teams? What permissions do they need? Your data scientists, they don't have the same permissions as your central teams, network and security teams. So you need to think that through. So when it comes to thinking about all of those, you need to then kind of take a path to implement that. Look at your organizational hierarchy, do that mapping, create that first. Do the functional to IAM map. Okay, so that's probably a spreadsheet where you're saying, okay, I know these guys or these gals need to be able to do that. Then determine where you need to attach that policy. And you need to audit all of this. So this is going to be an underlying theme, the auditing and logging. Okay, so let's just talk through an example so you can understand how this actually works. So here we have a central security and networking team in this organization. So they manage all the network and security policies. They've given each team of developers their own projects, but they're not allowed to make any changes to the network and security control. They are allowed to spin up instances. So before I go on to look at the IAM policies, I just need to introduce you to yet another control. This is shared VPC. This allows you to define an RFC 1918 network, which you can divide up into subnets. These subnets, the service projects, i.e. the projects that you've given to your developers, can then make use of. Okay? So there are actually three IAM policies that you need for this particular example. There are three because they're attached to different levels in the hierarchy and projects. Okay, so I'll just talk you through some of these. So the first one is attached at the organization hierarchy level. This is for the network and security admins. So there's two groups here, the network admins who've got managing all the network controls and the security teams that are managing the security teams. So all the security roles, sorry. Okay, and this is managed at the, attached to the organization level. First of the developer projects, this is on the host project. They need to be granted network user because they're going to be using that subnet that you're going to give them access to, which is in the host project. Okay, so they need to have network user in the host project as well. Second one is at the service project, i.e. the project that they spin these instances up in. They also need network user there as well, and they also need the ability to spin up an instance admin. Okay? So blending them all together, visually, you can see where the network and security admins have access to manage the shared VPC network in the host project, and you can see where the developers can use the subnets that's been assigned to their projects, and then they can manage the instances in their project. So looking at what users can do, there's Resource Manager to give you the hierarchical attachment points and central management, Cloud IAM for those granulated permissions, and Shared VPC, which allows you to have this central network and administration. Okay? You'll see this slide a lot. It's just to kind of give you a reminder of where they're coming from in the logical groupings. So at this point, I'd actually like to introduce Charlie from Verily, who's going to explain to you how they actually implement this within their organization. Thanks, Charlie.
Thank you so much, Grace. Hi, everyone. Welcome. I hope you have enjoyed your time at GCP Next thus far. My name is Charlie Aronson, and I'm a technical program manager working on cloud data security at Verily Life Sciences, an Alphabet company. As you heard from Diane and Sundar yesterday at yesterday's keynote, Google's mission is to organize the world's information and make it universally accessible and useful. Well, born out of Alphabet's moonshot factory, Google X, Verily has the mission to make the world's health information useful so that people can enjoy healthier lives. As you might imagine, working towards this mission can often take a number of forms. And many times, we realize this mission through partnerships. For some of these partnerships, such as Verb, focusing on surgical robotics, or on Duo, where we work on evolving diabetes management, GCP and indeed G Suite are at the core of our collaboration in terms of working together as well as developing together. In order to ensure that we're set up for success when using GCP, both internally and indeed for these partnerships, we've developed and follow a few key principles for cloud data security and operations. These are separability. We need to ensure that there is a clear differentiation in between different project teams and their data. Maintainability, thinking through how our systems are going to be used, not just today, but for years to come. And 3, simplicity, ensuring that we create and advise the use of understandable security configurations. So as you may imagine, bringing these principles into action often requires that we blend a few different GCP and G Suite tools and systems. Over the next few minutes, I'm going to explain how we use GCP hierarchy, G Suite groups, as well as Cloud Identity and Access Management, IAM, to accomplish and meet our principles. So let's start with separability. We need to ensure that our surgical analytics data is entirely separate from our baseline biological sample data. We do this by organizing our GCP hierarchy into folders, and then subfolders below that and project below that. That allows, as you can see on screen, for us to literally separate out the data and the subsequent access, ensuring that we adhere to the separability principle. Next comes maintainability. We organize our identities into groups. Then that are associated with a specific role or project within the organization. So to give you a tangible example, think of Allison and Charlie, who are both software engineers on a given project. They're contained within a group. And then the great thing about this is if we have another software engineer join the team, we just add her to the group, and she automatically has all the access that she needs to do her role. It's a fantastic way to ensure that we maintain the level of groups and access that we need. Next, rather than adding individuals to resources, we add these groups to resources via either a canned, widely available, or custom role. This allows us to focus on ensuring that we gate access at the group level and make sure that the appropriate people are in the appropriate groups. On a personal note, this has saved me an enormous amount of time in troubleshooting access requests and issues, and is fundamental to how we approach maintainability. Finally comes simplicity. By bringing together these practices, we work to create a consistent, understandable, and of course simple GCP access control system at Verily. We endeavor to use the platform as intended, rather than rolling our own solutions. And we are thoughtful about our hierarchy and where we grant groups access to resources to ensure that we maintain, of course, the appropriate access, as well as the appropriate separation. In using the platform as intended, we often find areas to give feedback to GCP, and this is fantastic. Our relationship with GCP has been really collaborative. And this is not just because we're an Alphabet company. This is because GCP is all about collaboration. So I encourage you all, go ahead, use your account teams, your support representatives, or a product forum to ensure that you provide feedback on how you're using the product to make it better for all of us. Data security and segmentation are of absolute paramount importance to Verily. Thus, in order to ensure that our teams and collaborations are set up for success, we have developed principles which guide our deployment of Google Cloud Platform, GCP at Verily. I hope I've been able to share some brief insights about how GCP is helping us realize our mission of making the world's health information useful so that people can enjoy healthier lives. Thank you all so much, and I'll pass you back to Grace.
Thanks, John. Thank you very much. Okay, so continuing on with the use cases, number 2, looking at enforcing what's not allowed. There'll often be the case that you'll want to have standard controls that are spread down throughout your org. But you want to do this without getting in the way of your developers. You still want them to be agile. GCP has something called organization policies. So the organization policy service, it allows you to provide standard controls that provide enforcement throughout your organization that you can override at different levels. Okay, so I'm just going to keep it simple and talk about colors. But for every resource that is supported by organization policy, there's a list of constraints that tell you how that resource can be restricted. So in this case, we're looking at a resource that's got 4 colors. You may recognize them. And in the standard here is the fact that you're only going to have 2 colors as the standard colors that are used within your organization. So red and green, this is your standard. But as ever, there's always exceptions. So the first group says, well, okay, we like the standard, but we also want to use blue. So you just add blue, so you can augment it. The other one says, well, we don't want our team to be able to use green. I quite like green myself. So they can only use red. And then the other 2, the standards aren't actually applying at all. So in this case, they've got an organization policy that's defined at the folder level for the first one, which is just yellow. And the last group, they're not having standards applied to them. They can just use whatever color they want. So you can see how you can be adaptable. So you can set the standards, but you can also flex to meet the requirements. Okay. So org policies and IAM policies are orthogonal, but slightly related. So org policies are all about how those resources can be configured, whereas IAM policy is about who can access those resources. Okay? Quite an important distinction. So moving on to look at how you can protect your GCP environment. Think of maybe like preventing data exfiltration. Think of that as being the use case as I walk through this. That would help, okay? So as you'd expect, there's a whole shopping list of controls that you can use for this particular use case. I'm just going to talk about some of the controls that I haven't already touched upon. So let's start with subnets. Subnets allow you to define a logical division in terms of traffic, okay? You can actually use it to kind of separate, your database backend from your application middleware. You can actually have different teams working in different subnets. And you can use it, when I say for HA deployments, is that you can obviously have subnets within different zones, okay? Firewall. The firewall obviously helps you to manage traffic between those subnets because traffic by default isn't actually between those subnets unless you explicitly define it. So the firewall is distributed. It's set up at the VPC network that you define it. It has, as you'd expect, ingress and egress rules, deny and allow rules. One of the things that I really, really like about it is the fact that you can have ACLed rules. So just to understand that, I'll just talk about firewalls with looking at service accounts to set up those rules. So service accounts are one of the identities I touched upon briefly early on. It's the programmatic identity for your VM or application. So using service accounts allows you to set up firewall rules in terms of intent, i.e., rather than thinking about, oh, what's the IP address of my web server or my database, you could think, I want to allow my web server to talk to my backend database. It actually helps to mitigate user error because you're thinking of, it's just more natural to think about it in that form. So it's authenticated rules, and obviously I'm excited and I really like it. Okay, so moving on. Just want to mention private Google access. This enables your virtual machines on your subnets to reach Google API endpoints such as BigQuery, cloud storage, via the Google network, so you don't actually have to go out to the public IP address. Okay? To supplement all those network controls, we have VPC service controls. VPC service controls allow you to provide a perimeter boundary to complement those controls. So it's defense in depth. This isn't a replacement for any of those. It's there to help mitigate data exfiltration risks, like from misconfigured IAM policies. Those things happen. Maybe to make sure that you know that people who are allowed to access your projects are allowed to access those projects. So I'll just go through a quick example so you can visualize what this actually means. Here we have two projects that are allowed to communicate with each other. So you've got the IAM controls, you've got the firewall rules set up between them. But as you can see, there are other paths in and out. You can have, an unauthorized client might be able to get to the data in your GCP service there. It might look scary, but we have something to kind of alleviate that pain. Service access zones. So here you can see that you define this perimeter. You define things like from trusted IP ranges. So if I talk you through the unauthorized client, can you imagine that you've had some sort of identity theft? Okay? It's highly unlikely that they are going to be using that identity to access your protected projects on that from your network. So it gives you a bit of time to mitigate the actual theft of the identity in that way as well. You can actually prevent, using the zone, you can actually define what it's not allowed to talk to. So you may decide that these projects, you don't want them to be able to write data to another cloud storage bucket or to BigQuery outside of those projects. So it kind of keeps them kind of covered up for you. Okay. So blending those together, you have IAM for the granulated permissions, you have the set of network controls, and then you have VPC service controls to complement all of those. Okay, so we've talked about what your users are allowed to do. Then let's talk about what they're not allowed to do, the unauthorized access. You need to manage who has access. You need to understand your users. So have a central repo is probably the wrong word. Have a central identity store that you manage your identities for. So you can use Cloud Identity. Or you can use, as I said earlier, you can use your own identity store. Use groups, as Charlie walked you through earlier. The OS login, this allows you to tie in who has SSH login to your instances with cloud identity. So you're managing that centrally. You give those users the correct IAM policy. They're allowed to actually SSH in. It's a central administration, so you're not worrying about actually setting all that with random keys being added to instances and metadata. Use IAM for least privilege. Stackdriver. Stackdriver is important because your logs monitoring is the first sign of any issues. So admin activity logs will tell you who's doing what, who's made an access call to particular sources, who started up that VM. Data access logs, who's had access to your data. You can use Cloud IAM to restrict who can actually view those logs. All right. And then you can do things like dashboards. You can export them to your own SIEM if you want. You can filter, and obviously you can alert on that. Service accounts. Service accounts are the keys to your door, so you need to manage them properly, okay? If you're running on GCE, then we manage the key rotation for you. We manage the rotation. You don't need to download them. The blast radius is minimized. We do understand that you do need to download keys, so even though I say avoiding downloaded production keys, absolutely understand that you might have applications that are running off-prem that you want to access GCP API endpoints. If you do that, you're going to have to implement processes to manage the downloaded keys. Use things like various tools to check that your keys aren't upgraded to GitHub. Okay. Put in policies for keys that expire quickly. Minimize the radius and the possibility. Use the key management service to encrypt your config files and your service account keys. Your service account keys are secrets, and then have a process to unencrypt and use them. And again, audit usage. So looking at that, unauthorized access, again, a number of controls, and this is just one way of actually thinking of dealing with this: key management service, Cloud IAM, and Stackdriver login. Okay, so now we've talked about managing and controlling your GCP environment. Now let's think about the fact you're running an application on GCP and how you protect that. So let's think about a web-facing application. So again, another set of controls that you can use to apply to this use case. Starting off with cloud load balancing, GCP has a number of cloud load balancing options, but for our use case, an application exposed to the internet, I'll just focus on the global HTTPS load balancer. When you enable the HTTPS load balancer, Google infrastructure mitigates and absorbs many layer 4 and below attacks, such as SYN floods, IP fragment floods, and port exhaustion, etc. It's generally used in conjunction with managed instance groups. Managed instance groups allow you to define a number of identically configured instances that can scale up and down. So it can absorb any attacks across those instances if you so wish to. Okay? In conjunction with Global Load Balancer, we have Cloud Armor. Okay? Similarly to the Global Load Balancer, that's a mouthful, it's distributed towards the edge of Google's network. So it can absorb attacks closest to the source. It's based on three main things. It's built on 3 pillars: a policy framework, a rich rules language, and the global enforcement infrastructure. It will help you defend against DDoS attacks. You can define security policies. You can do whitelists. You can block traffic. You can preview traffic. It's a very powerful tool that we've made available to help you with your web-facing applications. But it doesn't stop there. Okay. Identity-aware proxy. This is evolved from Google's Beyond Corp. It allows users who've got the right IAM policies, it will authenticate and authorize access to your web-facing applications. I'm showing it here working with Compute Engine and Kubernetes Engine. It works pretty much the same with App Engine. Okay. It's defense in depth, though, so don't forget to set your firewall rules up properly, and don't forget to make sure that you're mitigating any unauthorized SSH access. So we've talked about your user authentication and authorization. The next thing is what about your APIs? So an API proxy, think about it as an abstraction above your API layer. GCP has two types. It has a cloud endpoints, which is great if all your application is all in on GCP. It provides a management layer, and it will authenticate calls to the APIs. If, however, you want more enterprise-y type features, and it's multi-platform, then Apogee API Edge will be the one that you should be looking at. So IAP is for your users, and API proxies are for your authentication of your APIs. And your application code. And you need to be secure, and you need to trust it, okay? So use a security scanner for GCE and GAE. Make sure you're mitigating for the OWASP top 10. Know your code, so use private source repos, container registry, and container builder. Know what's in your code that you're deploying. So from one end to the other, there's the identity-aware proxy for your users who are accessing, Cloud Armor in conjunction with Global Load Balancer to mitigate, help block traffic and help mitigate DDoS attacks, and then API proxies for your APIs. All right. So finally and not least, I just want to talk about watching what's going on. So monitoring, alerting, and enforcing. So as you expect, we've got a collection of tools again. And as before, I'm just going to talk about the ones that I haven't already spoken about. So let's just have a quick look at VPC flow logs. So there was a great talk yesterday from Ines, the PM. So if you didn't catch it, then really go and watch it on YouTube. All about VPC flow logs. They allow you to get network telemetry for to and from your VMs, whether within GCP or whether it's coming from the internet going to your VMs. It allows you to, it's useful for forensics and security analysis. You can export to an SIAM. You can view this telemetry data within Stackdriver, so you can export to any of the syncs that Stackdriver supports, like BigQuery and cloud storage. Cloud Security Command Center. This gives you a single pane of glass, okay? It gives you a picture, a security slanted picture of your resources. It's modular, okay? It gives you an asset discovery and inventory. What's really cool about the inventory, you're working in the cloud, so you're going to be scaling up and down. There might have been, there might have been some instances in the past that have been used to do, Bitcoin mining. That's a big thing at the moment. Those were spun up, then spun down. You can still have insights into those spun down or destroyed instances. Okay, that's kind of a really nice feature of the Cloud Security Command Center. Got lots of other nice features, but that's the one that I really, really love. It integrates with the Data Loss Prevention API. Data Loss Prevention API allows you to classify your data, classify your sensitive data. If you want more information about that, there is the showcase where the DLP engineers are hanging around. Cloud Security Scanner to scan your applications. It allows you to integrate with third-party tools as well, and it gives you notifications. So Forseti is one of those tools it integrates with. Forseti is open source security tooling that's evolved from devolved from Google's internal tooling. It's a community-driven, it's open source, takes pull requests. It gives you an inventory. It allows you to enforce firewall rules. So if, for example, you have a standard that says, this is the firewall rules that I want to apply, somebody sets it back, Forseti will actually reset that for you. IAM Explain is really kind of cool because that gives you, it allows you to understand the impact of your IAM policies. All right. So the Forseti guides are also around here as well. So blending that together, VPC flow logs for your network telemetry, Cloud Security Control Command Center for your single pane of glass, Stackdriver login for who did what, where, and when, and for the alerts, okay? So I'd now like to introduce Arthur from Verily, who's going to talk to you about how they watch what's going on. Thanks, Arthur.
Thanks, Chris. Hi, everyone. My name's Arthur, and I'm a software engineer at Verily Life Sciences. I work closely with Charlie, building the services, tooling, and scripting to keep our healthcare data secure. So my section of the talk will be diving into the weeds a little bit on specific things that we've done to abide by best practices to keep the data as secure as possible. So there will be three big principles that we speak about today. One is how to generate, persist, and reasonably analyze your audit logs to look at who is accessing what data and security configurations. Two is looking at how to reasonably perform org-wide IAM policy reviews. You need to know what's in your policies to make sure that they're secure. And third is how you can perform company-wide rollouts and patches in the event that there's a security vulnerability that you've identified. So we'll first dive into logging. In healthcare, this is something that we're legally required to do for the most sensitive types of data, and it's generally a best practice that we should all be doing. And there's some questions that you may want to ask. For example, for a particular piece of sensitive data, who all or what are all of the identities that have accessed that piece of data? Second, you may want to look at who is setting security configurations in your project in the event that something was opened up too widely. And third is you may want to do diligence on a particular employee and ask what are every piece of data or every security configuration update that so-and-so has done at your company. Those are questions you may ask. So there's three big things that you need to guarantee when using Google Cloud Platform to make sure that you can answer these questions reliably. Number one is you need to turn on your audit logs. By default, your security configuration update logs are on, but your data read and data write logs are not on for projects. So it's imperative that you set these on at the project level IAM policy. And that you also, we'll talk about this a little bit more downstream, but that you check that they're never flipped off ephemerally. Second is that you need to export your logs. Now, the natural place that someone may try to export their logs is within the project for which the logs are being generated. However, we'll talk here shortly on why that's a very bad idea, actually. You may export your logs through a couple of different services on GCP. GCS exports to JSON. It's great for data robustness, not the best for doing analysis on your logs. They also export to BigQuery, which is our preference and probably the easiest place to really dive into those logs. And then if you need to build some real-time business logic on top of your audit logs, you can also export to Cloud PubSub. Now, the reason that I was speaking of earlier on why not to create a BigQuery data set in a project itself for which the logs are going to be dumped to is because oftentimes we set wide access roles at the project level IAM policy, and IAM is fundamentally hierarchical. So for example, if you use project editor, BigQuery dataset editor, BigQuery admin, storage object admin, storage object delete permissions, you're going to be giving a potentially wide group of people access to permanently delete your audit logs with no means of reproducing them. And if you're in the business of healthcare, that's something that we absolutely cannot have. So instead, we've adopted a different best practice, which is to export logs into a company-wide project where no individual has 24/7 access to this project, and we can ensure that our logs are never deletable by the teams for which we want to be auditing. Another key detail on this slide is that you can see, and Charlie spoke a little bit more about this earlier, we are pretty heavily using cloud folders to segregate different clusters of projects into different hierarchical paths. And this is very nice because now Cloud Folders has a feature where you can turn on audit logging for all children. So as long as the projects are generating the logs and the folder export is configured appropriately, you can have strong guarantees that every single audit log underneath some parent label or parent folder will be exported somewhere. And for us, we actually have one-to-one parity between our Cloud Folders and our BigQuery datasets in a company-wide super privileged project. And this will come into handy later. Okay, so the third principle with audit logs is that people need to actually look at them, or you need to run automated jobs to check for specific things. For example, who all has changed your project level IAM policy in the last month? Who what individual non-service accounts have accessed data that should never be accessed by humans. And the way that we've configured things that you saw in the last slide is that because there's this one-to-one parity between a cloud folder and a BigQuery data set, you can simply grant access to whatever groups have break glass access or superadmin access or TL access on the cluster of projects to their own audit logs with BigQuery dataset viewer so that they can read the logs and BigQuery job user so that they can actually run queries against them. This ensures that they can look at their logs, but also ensures that your logs will never be deleted and you won't be liable for that as a company. Okay, second big topic for the day is looking at how we can perform IAM security audits and some specific use cases for that. Going back to the previous slide, if we look at the clusters of folders, we can imagine that if a TL is responsible for some cluster, whether it's the data warehouse, the front-end serving app, the replicas in one folder, they want to be able to look at every single IAM policy or some IAM policy digest for their set of projects. Specific things you may want to check is that an identity outside of your organization does not have access to sensitive information. So, for example, if you're a company that hires a consultant and you decide to use that consultant's @gmail.com address, and at some point the deal is done and you want to remove their access, this can actually be a very complicated project. You can't simply delete their account because it may be their personal Gmail. So instead, you need to scrape every policy recursively and delete them. And the only really way to guarantee that is via this, I think, the folder structure and recursively crawling down and updating the IAM policies. Second big thing is you may want to do routine audits to make sure that only robot identities have access to some of the sensitive data in your project. So whitelist specific buckets, specific data sets, specific SQL instances, and ensure that no one's granted themselves access to look at it. Third is, as we were talking about earlier, you have to make sure that all of your projects have audit logging on and that this is never turned off by a user. So we should be auditing this. And fourth, and this is a problem that's plagued pretty much all of the cloud providers, is that there's a feature on GCS buckets and BigQuery datasets where you can make the data within them readable to the entire world without requiring any authorization. It's great for global research collaborations, but you need to make sure it's never on your most sensitive projects. So we at Verily have some very robust tooling around this to make sure that it will never happen to us. Okay, third topic that we want to talk about today is how to perform company-wide rollouts in cases of time-sensitive emergencies. Again, the folder structure is really paramount to performing this. So for example, one use case we had, which is the first one listed there, was there were 3 times in 2017 where we needed to patch every single VM in the company due to bugs like the global Spectra bug, which are bugs that affect the OS machines that Google doesn't control for your VMs. And to orchestrate this smoothly, the client is actually responsible for rebooting and patching every VM because Google is not going to randomly turn down your machines. It could affect production access. So by having the cloud folders, we are able to look at all the folders that don't serve production traffic, immediately roll out a job to reboot and patch their VMs, and then go team by team for ones that did serve production traffic, and with the consent of their TLs, recursively reboot all of their VMs for them. And as a result, we as a company were able to reboot thousands of VMs in a couple of hours. Whereas if you don't have this structure, it would be a nightmare to even track down the VMs in the first place. Second case where this is particularly useful is because we have a service account with super admin access at the top, we can pretty easily add people in, as long as there's a couple approvals, to grant break glass access to, for example, security engineers that find some mission critical configuration issue, or other people on a team in the event that the TL forgot to set up the on-call group appropriately and we need to give someone access to the project. And the third example here, which we talked about earlier, was being able to quickly crawl your entire GCP universe and remove a specific identity from all access. Okay, so at this point, I'd like to hand it back to Grace And we spoke a little bit about how Verily uses the best of GCP to secure our hypersensitive data. Thank you, Grace.
Thank you, Arthur. Okay, just to wrap up, and then for some Q&A. So, just a checklist. You need to define, when you start off thinking about what controls you need, define what your users should be able to do. Think about those controls, the IAM map, functional map. Think about what's not allowed, organization policy. And then think about what you're trying to guard and protect against. Okay, what are the threats? What are your concerns? Choose your controls from the shopping list. Remember, these are just a subset, and I've just kind of put them into a logical order. Blend those controls together for a defense in-depth approach, and monitor all the things.